Okay. Grade 7. Here is our lesson. Lesson 3 in chapter 10, probability of compound events. Here is the vocabulary you need to know: sample space, tree diagram, table. This you need to know. Okay? Now, so I started here. Probability of compound events, sample space. We need to define what is a sample space. It is all the possible outcomes you can get after you do the probability experiment. Now, here, as you can see, somebody, Suhaila. This is Suhaila. She wants to pack enough items to create 6 different outfits. 6 different outfits. Okay? So, as you can see, this is her arrangement. This is one arrangement which is not the same as this one, which is not the same as that one, like that. When she finishes all, that is what we are calling the sample space. All of these things she will list over here. Everything she will list on this column will be her sample space. And all these outfits she has labeled, this will be her outcome. They will continue until she finishes. Okay? So, what is a sample space? All the possible outcomes you get after doing a probability experiment. Now, how can you make a sample space? How can you arrange your sample space? You can arrange your sample space in 3 ways. Either using a list, or using a table, or using a tree diagram. So I will show you all of them. Okay? Now, in my car garage, I have 3 cars. Okay? There are 3 cars in my car garage. I want to arrange them in a row. So that means one car is there, another one is here, and another one is over there. So that's how I want to arrange them. Okay? In a row. Use a list, a table, and a tree diagram to find a sample space for the different ways I can arrange the cars. So I labeled my cars Mercedes with an M. I don't want to write the whole letter because I'll be repeating it. So just use one letter. If there are 2 M's, then you take the first letter and the second letter to differentiate. So my Mercedes is M, my Lexus is L, and the Toyota is capital T. Use capital letters, don't use lowercase. So in a table, I make my first outcome. I'll arrange the Mercedes, the Lexus, followed by the Toyota. Or I can start with the Mercedes, followed by the Toyota, then the Lexus. Or I can start with the Lexus, followed by the Toyota, then the Mercedes. Or the Lexus, followed by the Mercedes, then the Toyota, like that. Toyota, Lexus, Mercedes, Toyota, Mercedes, Lexus. How many outcomes do I have? 6 of them. These outcomes are not the same, even though you have the same letters. Here I am starting with the Mercedes, followed by Lexus. It is not the same when I have Mercedes, followed by Toyota. They are different. So that's why my answer is 6 outcomes, and this is how I arrange them in a table. Now, your table can be horizontal or can be vertical. It depends with you how you arrange them. Okay? Now, if I want to arrange my list, I just write them. Mercedes, Lexus, Toyota, Mercedes, Toyota, Lexus, Lexus, Toyota, Mercedes, Lexus, Mercedes, Toyota, Toyota, Lexus, Mercedes, like that. Toyota, Mercedes, Lexus. If you can see, MLT is the same here. MTL is the same here. LTM is the same here, like that. I just followed the same. So you can either arrange them in a table or you can arrange them as a list. And it's the same. If I count my list, how many items are in my list? 1, 2, 3, 4, 5, 6. 6 outcomes. Now, let me show you how to do this in a tree diagram. So, if you start with a Mercedes, you get a Lexus and then a Toyota. Or Mercedes, Toyota, Lexus, like that. There is your tree diagram. Lexus, Mercedes, Toyota, Lexus, Toyota, Mercedes. You draw. Toyota, Mercedes, Lexus, Toyota, Lexus, Mercedes. How many items do you count the last letters? You don't count the first one, you count the last ones. How many letters do you have? 1, because this is your first outcome. This is your first outcome. This is your second outcome. Okay? So 1, 2, 3, 4, 5, 6. 6 outcomes. And you have answered the question. Because the question told you to arrange it in a table, a list, or a T diagram. So you do one of them. If it says do all, then you must do all. If it says all, you must do one. You choose which one is it. No, you cannot choose. You must know all because you don't know if the question will tell you do all. So you must know all. Practice. Probability is difficult if you don't know how to read. If you read incorrectly, you will write incorrectly. You must read, you must practice. That's the only way this lesson will become easier. Okay? Now I want us to do example A in your book. Here is example A. So this person wants to make a sandwich. She went to Subway, she wants to make a sandwich. Subway is only having how many meats? 2 of them, chicken and turkey. And then, how many types of bread do they have? They have rye bread, sourdough, and white bread. They only have 3 types of bread. They are asking you to make a sandwich. How many different ways can you make the sandwich? That's the question. And they told you to use a list, a table, or a tree diagram. One of them. I'm going to do all. So, here. So I said chicken is C. I said chicken is C. I said turkey is T. I said rye is R. I said sourdough is S. Sourdough. I said is S. And I said white bread is W. Okay? Those are the letters, what they stand for. Now, if I choose chicken, I can eat with rye bread. If I use chicken, I can eat with sourdough. If I choose chicken, I can eat with wheat. That's the only 3 choices I have for chicken. If I choose turkey, I can eat with rye bread, turkey with sourdough, turkey with wheat bread. These are the only 3 choices I have with turkey. So altogether, I have 6 choices. These 6 choices are what I'm calling the 6 outcomes. Now look at my list. Chicken with rye bread, chicken with sourdough, chicken with white bread, turkey with rye, turkey with sourdough, and turkey with white. Here is my list. I get the same number of outcomes, 6 outcomes. Now, let us look at how the tree diagram will look. Here is the tree diagram. Chicken. Chicken with rye, chicken with sourdough, chicken with white bread. Turkey with rye, turkey with sourdough, turkey with white. And you can see, I told you you count the last letters. You have 6 of them. So that's why you have 6 outcomes. So this is what we are calling a tree diagram. A tree diagram of your outcomes, or a tree diagram of your sample space. Okay? So let's do another example. Let's define what is a compound event. For you to have a compound event, you need 2 or more simple events. You need 2 or more simple events. And your answer must be between 0 and 1. Remember that. Your answer must be from 0 to 1. Here. From, not between, from 0 to 1. From 0 to 1. That means 0 is included and 1 is included. Your answer can be a fraction or a decimal or a percent. Remember to simplify your fraction. Simplify. Your answer can't be negative. Your answer can't be greater than 1. If you do this, it will be wrong. If you get a negative, your work is wrong. If you get more than 1, your answer is wrong. So, let's say we have a family. So here is my example. Let's give an example. You have a family that have 3 children. So the children in a family can be a boy or a girl, but you have 3 of them. So we need to write the sample space for a family that has 3 children. So either all the children are boys, or the first child is a boy, the second child is a girl, the last child is a boy, or you have 2 boys and a girl. So the first child is a boy, the second child is a boy, and the last child is a girl. Or the girl is the first child, second child is a boy, the third child is a boy. Or you have the first child is a girl, the second child is a girl, and the third child is a boy. Or you have a girl, followed by a boy, followed by a girl. Or all the children are girls. So one of this is a possibility in this family. So if you have 3 children, this is your sample space. What is the probability of picking only girls? First I count. How many outcomes do I have? 1, 2, 3, 4, 5, 6, 7. So I have 7 outcomes. I write out of 7. Okay? Now, I want only girls. I can't choose this because there's no girl. I can't choose this because there's 2 boys. I want only girls. Here, I can't choose because there's boys. There's boys. There's boys. There's boys. So the only one that has girls only is GG. And there is my answer. The probability of only girls is 1 out of 7. The probability of only boys is this one. Only boys. Because here there is a girl. I can't choose that. All these other ones have girls. So 1 out of 7. And I always write here so that I remind myself what I am doing, to make sure I chose the correct one. Now, what is the probability of having 2 boys only? 2 boys only. I can't choose this because there's 3 boys. So by 2 boys only, 1, 2, 3, and that's it. Here there's 1 boy, 1 boy. Here there is no boy. Here there's 3 boys. I only want 2 boys. So I have 3 of them. So 3 over 7. What is the probability of choosing at least 2 boys? This means 2 boys or more. 2 boys or more. That's what this means. So 2 boys or more, that will be this one. 1, 2, 3, 4. So that will be 4 out of 7. What is the probability that the first child is a boy? So it's only 3 of them. Here, the first child is a boy. 1, 2, 3. So 3 out of 7. Okay? That the first child is a girl. 1, 2. I think I'm missing one more. I think it should be 8. Why do I have 3 boys? So wait. Girl, boy, boy. Oh yeah. I am missing one more. Should be boy, girl, girl. So there should be 8. So make here. So let's do this again. Where did I go wrong here? Probability of only girls, this is correct. So 1 out of 8. Probability of only boys, 1 out of 8. There, 1 out of 8. Only boys. Only girls, this one right here. Probability of 2 boys only. 2 boys only. 1, 2, 3. 2 boys only, 3. Yes. 3 out of 8. The probability of at least 2 boys or more. 2 boys or more. 1, 2, 3, 4. Yes, 4. 4 out of 8. And then the first child is a boy. 4. This is 1, 2, 3, 4. So 4 out of 8. Okay? And then the probability that the first child is a girl, 4 of them. 1, 2, 3, 4. 4 out of 8. Then you simplify your fraction. This becomes 1/2. This becomes 1/2. This becomes 1/2. Okay? These ones you don't need to simplify. So you make sure you write the correct sample space. You see how I checked here, the girls had 4, so I knew the boys also should have 4. So that's why I knew something was missing. As you're working, you're checking your work because you're about to make those mistakes. Check your work as you're working. See if your answer makes sense. Okay? And that is how you do the sample space for 3 children. And you can look at the example that they have over here in the book. You have 3 coins, you have a 5 fils coin, a 10 fils coin, and a 25 fils coin. So you can only get heads or tails on a coin. So if you do the first one, there is your sample space. Head, head, head. Or this one can be head, head, tails, like that. You do all of them. Now, what does the question want? What is the probability of getting 3 tails? You should have 8. 8 outcomes. 3 tails, this is the only one. Because here there is 2. Here there is 2. Here there is only 1 tail, like that. So 3 tails, this is the only one. So 1 out of 8. Same thing here. As you read, you make sure you do what the question wants. Okay? So, do example B. And let's look at example 4. To win a carnival prize, you need to choose one of the 3 doors, labeled 1 to 3. Then you need to choose a red, a yellow, or a blue box behind each door. What is the probability that the prize is in the blue or yellow box behind door 2? So you need to look at door 2. Door 2, you have 3 of them. One has the red, one has a yellow, one has a blue box. So you have 3 doors. You have door 1, 3, because you have 3 of them because of the red colors. Because of the red color, yellow color, and the blue color. So door 1 has 3 doors because you have a red box, one has a yellow box, the other one has a blue box. Door 2 has 3 of them because you also have 3 colors. And door 3, you have 3 doors of door 3 that each one has a red color. One has a red color, the other one has a yellow color, and the other one has a blue color. The question wants, you must pick door 2. That is one thing. You cannot pick any other door. You must pick door 2. And you must pick door 2 that has blue or yellow. So how many doors is that? 2 doors. How many outcomes do you have? Count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here you will have 2 out of all the 9. That is how you did that. If you read incorrectly, you will solve incorrectly. This is very important. You must read correctly. Do Aleph. I'll see you tomorrow.